Let us look at the topic indices. Now, suppose, all right, let's backtrack a bit for indices. And what we're going to do will lead up to what we're talking about when we mention indices, all right? Now, when you say something like 3 plus 3 plus 3 plus 3 plus 3, instead of saying 3 plus 3 plus 3 plus 3 all the time, you have another way of shortening the expression, because it could have been, how many trees you have here? 1, 2, 3, 4, 5. Suppose it was 15 trees, what would you do? You keep writing all 15 of them. 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. No. You have to have some way where you shorten it, and which would be a lot more convenient than to be having all these trees repeatedly. What you do, you say this is repeated addition. This is equal to, another way of saying it is here. You have 3 being added to itself. How many times? How many trees do you have? 5. You call that multiplication. And then you say, multiplication is a shortened way of writing repeated addition. So, that's what you have. Much shorter, much more convenient. If there were 15 trees added, lined up and added to each other, you would say 3 multiplied by 15, because you have 3 being the number repeated and there are 15 of them being added. So that's what you have. All right, so you remember that. Now let's continue looking at something else. Suppose you have, for example, 4 multiplied by 4 multiplied by 4. You have 4 repeated. But in this case, you don't have it added, you know. What you have is a case where it is multiplied. So you have repeated multiplication. It's no longer repeated addition. It's now repeated multiplication. So the question is, what would you do? Because you need to shorten the thing. Right? So what happened? The way you write this, you're going to have a 4, because definitely 4 is the number repeating itself. And somewhere you are going to have a 3, because there are 3 of them. But how do you write it? You cannot write 4 multiplied by 3 because it's not repeated addition, it's repeated multiplication. Now, here, you're not really going to have some symbol between the 4 and 3. Like, you're going to have something like this. No. The way you write it here is this. You write the 3 as a superscript. You see that? If you had 3 multiplied by 3 multiplied by 3 multiplied by 3, you would have 3 repeated. So you have the 3 is repeated multiplication. So you write the 4, because there are 4 trees, you write the 4 up here. See that? If you had 2 multiplied by 2 multiplied by 2 multiplied by 2 multiply by 2, multiply by 2. You have 2 in a repeated multiplication. So you have 2 here. How many 2's do you have? 1, 2, 3, 4, 5, 6 2's. So what you would do is have 6 up here. Alright? So here, 4 by 4 by 4. How you do it? If you want to get the answer, you say 4 multiplied by 4, that's 16. 16 multiplied by 4, that's 64. So the answer here would be 64. What would this be? 3 times 3 is 9. 9 3 is 27. 27 3 is 81. So this would be 81. How would you get this one? If you want the answer, you say 2 2 is 4. That's 2 squared is 4. 4 2 is 8. 8 2 is 16. 16 2 is 32. 32 2 is 64. So the answer for this would be 64. Alright, good, good. So you have them here. Now, here, this 4 here is raised to the power of 3. So what you say here is 4 raised to the power of 3. The 4 is what you call the base, and 3 is what you call the index. And all of this 4 to the 3 is in exponential form, right? This is the exponential form of writing 4 by 4 by 4. Alright? So, here, you have 4 raised to the power of 3. That's what you say here. In this case, this is 3 raised to the power of 4. 3 is the base and 4 is the index, right? 3 is the base, 4 is the index. 3 raised to the power of 4. This is 2 raised to the power of 6. 2 is the base and 6 is the index. So, here, this is the exponential form. Remember that. Make a note. Another way of writing it though, you know. Let's erase the answers. We're not really using the answers right now. And we don't want the board to become too crowded. Another way of writing it, if you're programming a computer, right, you would say the way you write it is 4. You have this little symbol called caret, and you have 3. This is 3 to the power of 4. This, you write it as 2 to the power of 6. In fact, some calculators, and remember you must have your scientific calculator. Invest in a scientific calculator. You will not be allowed in the exam with your phone. Even though your phone has a calculator on it, you're not going to be allowed in the exam with your phone or with any programmable calculator or with any smartwatch or any such device. It must be a simple non-programmable calculator, right? Scientific calculator. So here, talking about calculators, let's look at what. Let me draw for my calculator. Where's my calculator? I need my calculator. calculator. Alright. Here I have my calculator. I want to raise 4 to the power of 3. Now my calculator here, it have x to the y. So I say 4, I press the x to the, this is squared. 4, x to the y, and you see the caret come up there, 3, equal, and I get my 64. Now here, some calculator, and some calculator, the symbol for raised to the power of, like my calculator here, is x, and the y, superscript like that. So you say 4, press x to the y, you say 3, when you press equal, you get 64, right? Now, here, some calculators, that's not what they have. What they have is the symbol, the caret symbol. So you say, for example, 3, you press the caret, and 4. By the way, what would that give us? Let's look at it. Let's go back to our calculator. Oh no, my calculator went. I have to try again. Where is my calculator? So much calculator I have on the screen. Why my calculator keep going away? I want my calculator. Alright. This calculator remains. Now, 3 n to the power of 4 equals 81. And that's what we got before, right? When we were working out manually, we get 81. You see that? And then drawing for our calculator again. Calculator. We have 2 to the power of 6. 2. Press x to the y. And we see the caret up here. 6 equals. We get to our 64. So that's 64. And we have 2, this, and 6, and equal. And what we have is our 64. Alright, so that's that for now. So here we say with repeated addition, we shorten it by saying multiplied is the number that repeats itself multiplied by, and then we have the number of times that it is there. 3 plus 3 plus 3 plus 3 plus 3. There is 3 repeat itself. There are 5 3. So you say 3 times 5. 3 multiplied by 5. You know that would give you 15. Now, here, if we say 3 times 15, that will give you what? 450. So, I just say 15 3 is 45 and then add a 0. No, 3 by 15 is 45. Why I say 450? My mistake. 15 by 3 is 45. Alright? Now, if we have repeated multiplication, what we have is the number that repeats itself, and that would be considered the base, and the number of times that number is there. So we have a superscript, and that number of times, that's the index. So we say the base to the power of the index, 4 to the power of 3. And so on and so forth. So in a general way, if we have the repeated multiplication, x times x, I'll write 6 times x times, and so on, n times, there are n x's here, right? So you have n x's multiplied by itself. What you say? is x is the number that repeats itself, right? So x is there. It is raised to the power of n, right? So I write it a bit neater. So I say x to the power of n. X is the base, n is the index, and this is in index form or exponential form. Alright? So that is that for now. I will see you in the next video.